Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to solve one problem related to the Kuhn-Tucker condition. Basically, the condition provides the following equation for solving multivariable optimization problem with inequality constraints. So basically, let's write the equation first. Dow f by dow x I plus summation of j equal to 1 to m. Since we don't know the active constraints, we cannot identify them. So we are taking all n number of equations. So from I equal to 1, just the review, we already have covered this in the previous lecture. Okay, so second condition is lambda j gj should be equal to 0, which is j equal to 1 to up to m, and gj greater smaller than equal to 0, which is our inequality constraints. If the form is not like lesser than or equal to, we convert it into a form like that. And finally, the constraints. Language multiplier change there has to be. So these are the conditions. Always keep in mind that this corresponds to a minimization problem. So this corresponds to minimization problem. A simple conclusion is for a maximization problem, for a maximization problem, our lambda, Lagrange multiplier lambda j values has to be lesser or equal to 0. So this is easily derived using the similar idea that we have used with the direction, feasible direction S transpose by X transpose del F equal to your lambda 1 S transpose gradient of del G1 plus lambda 2 S transpose. So the gradient has to be positive for a maximization. So since the gradient has to be positive, so your lambda values in this case, these two will be greater or equal to basically greater than 0. So this one is greater than 0, and also this one is greater than 0. So to make the overall function negative, your lambda values has to be lesser than 0. So the lambda value has to be lesser than 0. In this case, 1, 2 we can say, but why this negative sign, the equality sign is there? Because we don't know the inactive conditions. So inactive conditions are given by this. And active conditions are given by del j not equal to 0, but for maximization, it has to be lesser than 0. Okay, so let's begin our problem with this eliminate idea. So this is a generalized minimization case criteria. In the maximization, only one thing is being reversed. That is your Lagrange multiplier values. Apart from that, everything has to be the same. Okay, so now start solving the first problem. Example 1. Example 1. So this is a maximization problem. I'm not sure, probably it's taken from book or from the internet, not sure. Just check fx equal to 2x1 square minus 7x 2 square plus 12x1 x2. And the subject to 2x1 plus 5x2 lesser than equal to 19. And also always a condition, even if it is not mentioned, we always assume that x1 and x2 greater than 0. So this is always the assumed direction. Now, values for your system variable x. So now form the Lagrange function first, and also the condition that is given, which is inequality condition this. So we have always said that we will be writing this condition in a form like this: g of jx will be this or equal to 0. So if you write this in that form, then it becomes 2x1 plus 5x2 minus 98 less or equal to 0. And now from the Lagrange function, so your L is a function of x2, and there is only one constraint, so only one lambda will be necessary. So x1, x2, and lambda. So the function is 2xn square minus 7 x2 square plus 12x1 x2 plus lambda times our constraint that is given to x1 plus 5x2 minus 90. So this is our Lagrange function. And our constraint g of x1 and x2 is 2x1 plus 5x2 minus 90. So we now start finding the derivatives. So now L by now x1. First with respect to x1, then with respect to x2. That will be 2 into 2, so basically 4 x1 plus 12 x2 plus only the first one there. So plus 2 lambda equal to 0. Similarly, I'll write dou L by dou x2 will be 7x, so minus 14x2 minus 14x2 plus 12x1 plus only this will be available, so it's 5 lambda is equal to 0. Okay. Then with respect to, so once we have done this, then we have second one is lambda times g, lambda j, gj should be equal to 0. So that implies that in our case there is only one lambda, lambda times 2x1 plus 5x2 minus 8 should be equal to 0. So this is our according to the Lagrange Kuhn-Tucker condition. This is equation 1. This is equation 2. Okay, so this is first two equation. Then third equation is basically the condition, the constraint itself. So 2x1 plus 5 x2 minus 98 is lesser or equal to 0. And condition that is given, x1 greater than 0, x2 greater than 0, as well as lambda. Since it is a maximization problem, it has to be either equal to or 0. Okay, so this is our conditions. So first two is to solve the values as we have said previously, find out x dot and lambda dot, lambda star, x star and lambda star, and this two is to check whether our result is true or not. So check or validate the results. Okay, so let's proceed with solving equation 1 and 2. So equation 1 has two parts. So if you want, you can say this is 1a and 1b. So now solving this two. And also two conditions are there. So since there is only one lambda, so we have two conditions to check. The case one is lambda equal to 0, and case 2 is lambda not 0. From where it is coming? This is inactive constraint case, and this is active constraint case. So step by step, we'll be following basically equation 1 and 2. We'll be solving equation 1 and 2 for both cases, lambda equal to 0 and lambda not equal to 0. And then once we have the solution, then we'll validate using these other two equations. So this equation we can call 3, these equations we can call 4. So let's proceed with the case 1. Case 1, that is equal to 0. So first equation, or equation 1a becomes 4x, lambda values are vanished. So 4x1 plus 12x2 is equal to 0. And in the second equation, 12x1 minus 14x2 will be 0. So if we solve this one, we can figure out that the values of x1 and x2 is becoming 0. Okay. And what is the value of lambda? Lambda we already assume that lambda equals 0. So all three are 0. So now check the conditions. Check the conditions. Basically, 2x1 2x1 plus 5x2 minus 98 to 2x1 plus 5x2 minus 98 should be equal to less than or equal to 0. But since both of them are 0, we find that minus 98 is basically lesser or equal to 0. Okay. So this is satisfied. Second one is our values of x1 and x2 has to be greater or equal to 0, which is also true. Okay. According to the given condition basically. So by mistake I have written greater than nothing is greater than 0. So this is true as well. So satisfied. And also lambda values in this case are equal to 0. That is also satisfied. Okay. So what will be our values of f values? So x1 star is and x2 star both are 0, as well as your function fx, fx1, x2, or simply fx is equal to 2x1 squared minus 7x2 squared plus 12x1 x2. All 0, so 0. This you can also write star. Now the difficulty here is, since all values are 0, it's difficult to find whether the result is correct or not. But there is doubt. What is the doubt? The doubt is that lambda is 0, so this condition generally should give an inactive constant gains. Inactive constant is so with all 0 values, we have to go for the next condition. So check for next condition. Check for next case. Okay, so lambda not equal to 0. So now your difference equation becomes 4x1 plus 12x2 plus 2 lambda equal to 0. Then 12x1 minus 14x2 plus 5 lambda equal to 0. Similarly, your condition, since lambda is not equal to 0, so your other part is equal to 0, that is 2x1 plus 5x2 equal to 92. So from where it came? Because your lambda g in this case should be 0. Since lambda is not equal to 0, so g has to be equal to 0. So g is nothing but 2x1 plus 5x2 minus 19. Lesser. So now instead of lesser than, it will be equal to 0. So now out of these 3 equations, we find out the critical point. So out of the 3 equations that we call it as 1, 2, so 1 times 5 minus 2 times 2. Basically, we are trying to eliminate the lambdas. So that will give us 20x1 plus 60x2 plus 10 lambda equal to 0, and 24x1 minus 28x2 plus 10 lambda equal to 0. So this will give us minus 4x1 plus 88x2 equal to 0. So this is the equation number 4. Similarly, equation from other two equations also now using equation 4 multiplying with 2 and then adding with equation number 3. Okay, so basically we want to eliminate x1. So that will give us 4x1 plus 10x2 equal to 196. Minus 4x1 plus 88x2 equal to 0. So if you add these two, then this will give us 98 x2 equal to 196. So x2 will be basically 2. So now from equation now 2x1 plus 5x2 from basically equation 3. X2 can be replaced by 2 equal to 98. So basically 2x1 equal to 88. So x1 will be 44. So x1, x2 is already calculated. So find out the values of lambda. What do you have to do? You have to set this value in any of the equations. So in equation 1, we set the values and we check that 4 times 44 plus 12 times 2 plus 2 lambda equal to 0. So 2 lambda equal to minus 200. So lambda equal to basically minus 100. So two values we obtained. Let's know the values are obtained. Now conditions. So first condition is x1 is greater than 2, which is greater than 0, which is validated, as well as x2 is greater than 0, and our lambda is lesser than 0. So these three satisfied. What about the constraint? Constraint that is 2x1 plus 5x2 minus 98 should be less or equal to 0. So 2 times 44 plus 5 times 2 minus 98 is it's basically 0. The equality condition is satisfied. So once all these conditions are satisfied, now we can go for picking the optimum value of f. So f max or f star x1, x2, or you can also write f x1 star x2 star. I think this one is more common. This is rarely used, so we can also avoid this. 2 times x1 square minus 7 times x2 square plus 12 times x1 times x2. So this will give us a value of 4900. So your F max is 4900. So as you have seen that even the first condition was satisfied, but because of the fact that all of the results become zero, we had to go for checking the second condition. And we eventually figured out that previously F max was zero, which is not true because in the second case, we have achieved the true maximum, which is 4900. So that is why if all of the conditions is becoming zero, it is wiser to check the other condition. It may happen the other condition can also give the same result in this case. In that case, we'll accept that result. Otherwise, we'll take the correct result. So this is the first problem, and hopefully we'll try to see a few more problems related to this in the next section. Sure. Assalamu alaikum.